Welcome to Math 8 class. Now, we're going to discuss the history of polynomials. The word polynomial joins two diverse roots, the Greek poly, meaning many, and the Latin nomen, or name. It was derived from the term binomial, by replacing the Latin root pi with the Greek poly. The word polynomial was first used in the 17th century. Greek mathematician Pontos of Alexandria is the father of polynomials. This is Vernet's cards. 16th century, he discovered analytic geometry. He also made significant contributions to the theory of equations, including coming up what he called the rule of signs for finding the positive and negative roots of equations. In light geometry, 1637, he introduced the concept of the graph of polynomial equations, and the equations is ax squared plus bx equals c in the general formula for a polynomial, where the a's denotes constant and x denotes a variable. Descartes introduced the use of superscripts to denote the exponents as well. Let's recall. So, remember me and I will remember you. Directions following the pattern in squaring a binomial. Fill in the missing term. Number 1. Quantity x plus 2 squared. Blank plus 4x plus 4. What is the answer here? X squared. How do you get the x squared? Just multiplying x times x. So that's x squared. Number 2. Quantity 2x minus 3 squared. 4x squared negative blank plus 9. The answer is 12x. How do you get to 12x or negative 12x? Just multiply 2x times negative 3 with square of the exponent. So it means that is negative 2 times 2x times 3. So that is negative 12x. Number 3, quantity 3x plus 4 squared. 9x squared plus 24x plus blank. The missing is the last term. The answer is 16. How do you get the 16? That is 4 times 4. And that's 16. Am I a perfect? The baby says, am I nobody? Nobody's perfect. Therefore, I am a perfect. Determine whether the given expressions are perfect square trinomials. Write P if it is a perfect square trinomial, and N if not. So I give you the hint. To know the perfect square trinomial, first observe the terms. It must be trinomial. It must be 3 terms. The second one, just take a look for the first term and the last term. So the first term must be perfect and the last term must be perfect also. So let's now start. Number 1, a squared negative 22a plus 121. Is that P or N? Alright, that's P, a perfect square trinomial. Number 2, b squared negative 8b plus 16. That is P, a perfect square trinomial. Number 3, x squared plus 7x plus 10. That is N, not perfect square trinomial. 4, 4d squared plus 20d plus 25. That is perfect square trinomial. And number 5, x squared plus 2x negative 15. That is not perfect. Okay, so let's examine the 1, 2, and 4. Why they are perfect. They are called perfect square trinomial. The number 3 and 5, that's n, are not perfect, and that is called a general trinomials. We will going to discuss the perfect square trinomials and general trinomials today. Now, let's go on to the next slide. Quarter 1, Module 1b, Factory Perfect Square Trinomials and General Trinomials. Being happy doesn't mean that everything is perfect. It means that you decided to look beyond the imperfections. So let's discuss the perfect square trinomial. It's the result of squaring a binomial. A perfect square trinomial has first and last terms, which are perfect squares, and the middle term is twice the product of the first and last terms. To factor the given trinomial, let's discuss the steps. First, examine whether the first term and last term are perfect squares. Second, look at the middle term. Check whether it is twice the product of the square root of the first term and last term. Third, if conditions 1 and 2 were satisfied, then the expression is a perfect square trinomial. Fourth, factor completely the given trinomial following the pattern a squared plus 2ab plus b squared equals quantity a plus b squared or quantity a plus b, quantity a plus b. Similarly, a squared negative 2ab plus b squared equals quantity a negative b squared or quantity a minus b, quantity a minus b. Example number 1, factor n squared plus 16n plus 64. Now let's do first the first term. The factor of first term is n. We can write the n squared into quantity n squared. For 64, the factor of this is 8. We can write this quantity 8 squared. For the middle term, we said that is twice the product of first and the last term. So take note. To find the middle term correct, you have to examine here. If you're going to multiply the first term and the last term, and the result is not same with the middle term, so it means that is not factorable. Okay, so now let's check this. So find the answer here. We have quantity n plus 8 squared. Or we can write quantity n plus 8, quantity n plus 8. Number 2, factor 4x squared plus 4x plus 1. First term, that is quantity 2x squared. And the last term, that is 1 squared or quantity 1 squared. Then check out the middle term. It must be twice the product of the first and the last term. So you have the twice here. First term 2x, last term 1. So when you multiply this and the answer is 4x, so it means the factor for the first and the last term is correct. So the answer here is quantity 2x plus 1, or we can write 2x plus 1, 2x plus 1. Number 3, factor x squared negative 12x plus 36. That is quantity x squared. And this is quantity 6 squared. To check the middle term, it must be twice the product of the first and the last term. Alright, so you have negative 2 times x, that is the first term, and the last term is 6. So when we multiply this, and the answer is negative 12x, so it means our factor for the first and the last term is correct. So take note, if the middle term is negative, it must be a negative sign here also. So always check the sign of the last term. If this one is negative, it means there's something wrong in the given, or we can say that is cannot be factored. So here the answer here is quantity x minus 6 squared. Or we can write quantity x minus 6, quantity x minus 6. Number 4. Factor 3x squared negative 18xy plus 27y squared. Let's do the first term. Okay, as you can see here, 3, 18, 27 has common, which is the GCF, or the greatest common factor, is 3. So take out first the GCF, which is 3, and then we have here the x squared and negative 6xy plus 9y squared. We do the first lessons once from the module 1a, which is the common monomial factor. And then the second, examine or observe the first term and the last term. So this can be factored as perfect square trinomial. So let's do the first term. We have quantity x squared, and the last term is quantity 3y squared. Now let's check it out, the middle term. Since twice the product, just copy the sign for negative. That is 2. This is 2 is twice for the product with the first term, that is x, and the last term 3y. So if we're going to multiply this, it must be same with this. So negative 2 times x is negative 2x times positive 3y, that is negative 6xy. Therefore, the factor for x and for the last term is correct. So again, check it out, the sign of the last term. If it is a positive, it must also positive. So the answer here is 3, which is the GCF, quantity x minus 3y squared. We can write 3 quantity x minus 3y, quantity x minus 3y. We're done in perfect square trinomial. So now we're going to discuss the trial and error. So I would like to share these quotes. There are no mistakes, only lessons. Growth is a process of trial and error. So take note, we do the trial and error here. So that's a part of our growth. So, this is the general trinomials. Can be classified into 2 ways. The first one, where a equals to 1, and the second one, where a is not equal to 1 or a greater than 1. Let's have the example number 1. Factor x squared plus 7x plus 10. So let's examine the first term and the last term, because we will do the first term and the last term first. Here, we can categorize here in number 1 because our a here is 1. So x squared, that's x times x. Then for the last term, positive 10 times positive 1. Just exclude the sign. Then to check out the middle term, let's cross multiply. 1 times x is positive x. Then 10 times 1 is positive 10x. Now, this is same positive sign. So if it is positive sign, you have to add. So 10x plus 1x, that is 11x. Did you think the middle term is same in the original equation? That is wrong. and that is no. So it means we do the trial and error. So let's do the another one. X times X. 5 times 2. 5 times 2 is 10. X times X is X squared. So let's do the cross multiply. This is 2X and this is 5X. Both positive, you have to add. So it means we have positive 7X. Did you think the original equation is same in the middle term here? Yes. So it means to find the answer, you have to choose this. X plus 5, X plus 2. So that is the final answer. Number 2. Factor x squared plus 2x minus 15. Factor first the first term, x times x. The last term include the sign negative 5 and positive 3. Let's do the trial and error. Let's check if the middle term is positive 2x. Multiply positive 3 times x, positive 3x. And this is negative 5x. Negative, positive, that is subtractions. You're going to subtract, then copy the sign of the higher number. That is 5. So we have negative 2x. Again, unlike sign or different sign, you have to subtract. That's only for the middle term. And then copy the sign of the higher number. The higher number is 5 and the sign here is negative. So just copy negative. So we have negative 2x. So therefore, that is not positive 2x because we have a different sign here. So it means our factor here is wrong. So let's do the another way to find the answer. X times x, and then I use positive 5 and positive and negative 3. So cross multiply negative 3x, positive 5x. Unlike sign or different sign, subtract, then copy the sign of the higher number. That is positive 2x. Oh, right. So here we have same middle term. So therefore, the answer here is x positive 5 and x minus 3. We can write as this. Number 3. Factor x squared negative 5xy negative 24y squared. Do the first term, x times x, then the last term, negative 8y, positive 3y. And check it out, the middle term, cross multiply. We have positive 3xy and negative 8xy. Different sign or unlike sign, you have to subtract and copy the sign of the higher number, which is 8. And that is negative 5xy. That is same with the middle term of the original equation. Therefore, that is the answer. Then write x negative 8y, then x positive 3y. Example number 4. Factor 6x squared negative 5x negative 6. Where a is greater than 1 or a not equal to 1. So let's factor first. 3x times 2x, and this one negative 2 times positive 3. Cross multiply, positive 9x, and this one is negative 4x. Then this is different sign or unlike sign. So when this is different sign, you have to subtract and then copy the sign of the higher number. So take a look, the middle term here is not negative. So therefore, these factors are not. So let's take another one. Factor 3x and 2x, that is for 6x squared. And we have positive 2 and negative 3. Then cross multiply with negative 9x, and this is positive 4x. Different sign, you have to subtract, copy the sign of the higher number that's negative. So this yes. The middle term here is same, so therefore the answer here is 3x plus 2 and 2x minus 3. You can write this in quantity like this. Okay, example number 5, 3x squared plus 17x plus 10. For 3x squared, we have 3x times x. For 10, we have 2 times 5. Then cross multiply, 15x, and then here's 2x. Then same sign, you have to add, so that's 17x. So therefore, the middle term is correct. So the answer here is 3x plus 2 and x plus 5. And we can write as this. Now is your turn. Have fun. Factor the following completely. Number 1, y squared plus 20y plus 100. What is the answer? Quantity y plus 10 squared. Or we can write y plus 10, y plus 10. Number 2, k squared negative 8k plus 16. The answer here, quantity k minus 4 squared, or you can write k minus 4, k minus 4. Take a look. The sign in the middle term is negative, so we use the middle, which is negative. Number 3, 16m squared negative 48m plus 36. 36 is a perfect square, and 16 is a perfect, and also the m squared. So therefore, that is perfect square trinomial. And take note, we have the negative sign here. So you must use the negative in your answer. So what's the answer here? Quantity 4m minus 6 squared. Or we can write quantity 4m minus 6, quantity 4m minus 6. Number 4, c squared negative 3c minus 4t. First term and the last term is not perfect, so therefore that is general trinomial. So what is the answer here? Quantity c minus 8 and quantity c plus 5. Last, number 5. 3x squared negative 5x negative 12. 3 is not perfect, and 12 also is not perfect. So it means that's general trinomial. What's the answer here? The answer? Quantity 3x plus 4, quantity x minus 3. You're doing a good job. Alright, thank you very much. See you next meeting.